Hello guys, I'll just check the audio and video here. We'll start our session. Give me a moment guys. Yes. Hello. Yes, it's perfectly okay. It's functioning fine, guys. So we can start our session. So let's wait for a minute. We'll wait for people to come. Once they'll come, you will start our session. So we'll give 1 minute. So meanwhile, if anyone is having any doubt regarding complex numbers, yes, you are always free to ask. Okay, so we can start our session now. Hi, good evening everyone. So I welcome you on in Let's Crack JEE in English, and this is complex number 2, lecture number 2 in complex numbers. So last time we covered the algebraic operation, the Argand plane, how exactly we can see one complex number in so basically I can say geometrical interpretation, geometrical representation of a complex number. This is what we covered, algebraic operations, and we solved a few questions. I'm really sorry guys, just these hiccups are creating issue. Those whosoever is joining me the very first time, this is my small introduction. This is Nishant Khanduja. I graduated and post-graduated from IIT Bombay. My rank in IIT was 1256. In AIEEE it was 363. In Rajasthan pre-engineering test, this rank was 4. I traded in US and Canada markets for 2 years. I have a teaching experience of 8 years. And one thing which is not written here, that is it's my wish, it's my something very close to my heart. That is, I want to teach people, those who are there in tier 3, tier 4 cities and villages, those who want to crack competition like iit-jee. So I want to teach them. That's my main motto, because I know what they went through. Yes, why what they go through, why they're not being able to join coaching institute. So there are many reasons. So in crux, so I always feel as they also have the right to prepare for examination like iit-jee. So with this thought, I ended up joining crack iit-jee campaign run by Unacademy. This is India's largest campaign, where I'm doing my small part by teaching you guys mathematics for JEE. Now, if you want to learn from me, what you need to do? You need to simply install an Unacademy learning app. When you install it, you get two sort of packages. One is plus subscription, another one is iconic subscription. Plus subscription, in this you get what? Daily live classes. So these daily live classes are apps. I'm really sorry. These daily live classes are completely different from YouTube live classes. So where you get to interact with the educators live. You also engage yourself in the discussion. You can ask questions. You can be a part of a polling system also. So everything can I can say it's next to offline classroom experience. Whereas also you also get to attempt live tests and quizzes. You can evaluate your performance, how well you have studied a particular topic. You also get to attend structured courses. So these structured courses are designed by all these top educators. Sorry guys, just give me a moment. Let me just have water. With something, just it's happening with me since morning. Sorry guys, just give me a moment. Just give me a moment, I'll come. Yes guys, I'm sorry for the delay. Okay, so you also get to attend or you can watch unlimited. You also have the unlimited access to the recorded videos by all the top educators. So whenever you have the time, you can just watch them whenever, wherever. So according to your comfort, that's all up to you. Similarly, in Iconic subscription, you have all these benefits, but apart from plus subscriptions benefits, you also get to have 3 benefits. So you have personal coach. So this personal mentor, he's the person, he will help you out to strategize your examination strategy, what to do, what not to do, because he's the right person who knows your strengths and shortcomings. And you also have test analysis report that would tell you that where exactly you're losing marks, in which session, how you can reduce your negative marking. It also helps you to improve your time management and examination approach. We also have study planner that customizes the study plan according to students' need. It also reviews students' progress bi-weekly, and if at all any changes are required, it would incorporate them in your study plan. So when it comes to buying these packages, there are options available. You can go for 6, 12 or 24 months. I would suggest people, those who are there in 11th standard, they must go for 2 years package. Reason is very simple. One is it's a 2 years process, so no one would like to discontinue his or her preparation before the examination gets over. Very simple. Second is, since it's a 2 years preparation, all the educators, they have designed the entire course in such a manner that within this time span you can peacefully cover the syllabus after understanding each and every topic. If you discontinue between, you would end up skipping a few topics, and that would result into losing marks. So I know, yes, no one would like to risk that. And third is, it's very cost effective. Look at the cost. It's 2,333 rupees per month. If you just look at the per day price, what it is? 78 rupees per day. It is nominal. In this price, you are getting top educators for one day. That's impressive. I literally accept this fact. I appreciate this fact. And the price what you need to pay for this is 56,000 rupees for 2 years. But if you want more discount, you can apply my code NK001 and the price would become what? 50,400 rupees. People, those who are there in 12th or they are dropper, they must go for this package. 1 year. The cost is 38,500 rupees. The price drops down, and if you apply my code NK001 and the price becomes 34,650 rupees. Similarly, for Iconic, the price for 2 years subscription is 86,000 rupees. It reduces if you use my code NK001 and the price becomes 77,400 rupees. For 1 year, it is 56,000 rupees. This price reduces if you apply my code NK001 and the price is 50,400 rupees. So these are the packages pricing. You can buy these packages according to your comfortable according to your comfort zone, but I would suggest, since already courses are running, so you go for these courses as soon as possible, because I do not want you guys to just miss out on time. You should have enough time while preparing for this sort of competitive examination. Okay guys, so my job is just to teach you guys, so I'll keep teaching you. Meanwhile, that's your job, that's your bit, you have to do it. Okay guys, so let's move ahead. Yes, that's what we have studied in the last class. So now we'll start from here. How to calculate a square root of a complex number. So let's assume that you have been given a complex number like this. And you have to calculate its square root. Let's say when you take the square root of this number, we get this number, x plus iota y. So how can I calculate the square root of this number, a plus iota b? What can I do? So what I can do is, I can square both the sides, and then I can compare and calculate the value of x and y. What do you think? I guess this is what we can do. So if I square it, so x square minus y square plus twice of iota xy is equal to what? A plus iota b. Correct? Now if I compare it, so what do I see? X square minus y square is equal to what? A. Twice of xy is equal to what? B. Here? I'm sorry guys. Now I need to solve these two equations. So what can I do? Tell me. Think over it and let me know. Meanwhile, I'll just have water. Sorry guys for the hiccups. Okay. So what I can do is, I can calculate x square plus y square. How can I calculate? Yes, this is the way. X square minus y square is whole square plus 4x square y square, right? Now I can punch the values of this. So this becomes a square plus square of this is what? 4x square y square. So this is b square. Here. Now let's say this is equation number 1 and let's say equation number 2. Let's add both of them. When you add 1 and 2, what do you get? Twice of x square is equal to what? A plus root of a square plus b square, correct? So now x will be what? Plus minus 1 by 2 a plus root of a square plus b square. Sorry guys, right? Similarly, y will be what? Y will be equal to, I can just subtract. When I subtract from this, from equation 2 to equation number 1, what do I get? Twice of y square will be equal to this root of a square plus b square minus a, then divided by 2, and let's take the square root, plus minus 1. So this is your y. I'll just clear it out so that you guys don't get confused. So if anyone has any doubt, you're free to ask. Okay guys, so that's how you can calculate the square root of a complex number. Okay. One more thing I would like to mention here. Let's say if x and y both are of opposite sign, so what would you see? You would see b as negative, correct? So remember this fact when you are writing the square root, when you are choosing the plus minus sign from y and x. So I must say, I would suggest that you better look at the sign of b. Okay, if your b is negative, then x, y need to be of opposite sign. Okay, remember this. Let's calculate this. Square root of minus 15 minus 8 iota. So let's assume that x plus iota y is what? Root of minus 15 minus 8 iota. Let's square it. So x square minus 5 square is minus 15. Similarly, twice of x, y is equal to what? Minus of 8. Okay. Now, before solving, as you can see, it's opposite sign. So remember this. So x square plus y square will be what? Square root of 25, 2 to 5. Plus, this is what? 64. So we have what? 289 square root. This is what? 17. This is, let's say, equation number 1. This is equation number 2. Let's add them. When you add them, what do you see? Twice of x square is equal to what? Minus 15 and 17. We get what? 2. X will be what? Plus minus 1. Similarly, y, if you want to calculate, so when you know x is 1, you can punch it here. So this is 1. So you will have 1 plus 15, 16. So y will be what? Plus minus 4. So when I am about to write the answer, x plus iota y, now tell me, what will I write? I'll write 1 minus iota 4. Why? Because it's very simple. The reason is, because if I put plus both the sides, my multiplication, the xy, product of xy will be what? Positive. Whereas it is given negative. So I have to make sure it turns out to be negative. So when your x is positive, your y is negative. When y is positive, your x is negative. Okay. So this is the square root of minus 15 minus 8 iota. I hope everyone got this. Okay guys, let's move ahead. Okay. Calculate all the possible values of root iota plus root minus iota. So what you need to do, again you need to calculate the square root of these two functions, right? So let's calculate the square root of iota. So square root of iota is what? So x plus iota y is equal to what? Root of iota. Let's square it. So x square minus y square is equal to 0, and twice of x y is equal to what? 1. Okay. So x square plus y square will be what? 1 only. Let's add both of them. When you add both of them, y square will cancel out. So you have what? Twice of x square is equal to what? 1. So your x will be what? Plus minus 1 by root 2. Clear? Similarly, y will be what? As you can see, it's positive. So x and y both will have the same sign. So when you put y by root 2, x is 1 by root 2. So y comes out to be what? 1 by root 2 only. Clear? So this is the square root of root iota. Let's talk about this. Root of minus iota. So a square minus b square is equal to what? 0. Twice of ab is equal to minus 1. So we have a square plus b square as what? This is root of 0, root of 0 plus 1. So 1. Let's add both of them. When we add both of them, so this b square will cancel out. So I have what? Twice of a square. So a will be what? Plus minus 1 by root 2. Whereas b will be what? Opposite sign, because as you can see, it's of opposite sign. So minus plus 1 by root 2. Clear? So square root of this will be what? 1 by root 2 is common. So plus minus 1 plus iota, and this will be what? Minus plus 1 by root 2. 1 minus iota. Clear? So let's see how many options are possible. When I take plus from here and negative from here, so one option would be 1 plus iota, and this is minus 1 by root 2, so this will cancel out, so plus. So root 2 iota Then if I take plus from here, so 1 will this will add up 1 by root 2, 1 by root 2. So I'll have root 2 only. Then if I take negative from there and negative from here, so minus 1 by root 2. Okay, so minus root 2. Your iota terms will cancel out. Clear, guys? When I take minus from here, plus from here, so what do I see? Minus 1 by root 2 and plus 1 by root 2. This will cancel out. So I'll have negative of iota root 2. So these are the 4 answers you get. Okay, guys? So this is the square root problem. So obviously you would not face these sort of problems a lot, but it's a operation. Everyone should know how to calculate the square root. Okay, guys? Let's try to represent this complex number in polar form as well as Euler form. So what is this polar form? So if you remember, in a polar system, we represent any point by its direction from the origin and the angle it makes with the x-axis. Correct? So let's say this is the point. So the coordinate for this point will be what? Comma theta. So this r is what? R is the distance here from origin, and theta is the angle with the x-axis. Clear? So how do you represent in polar form? So let's say z. This is what? X plus iota y. General term. So in polar, it will be represented by r, which is the magnitude. R is what? R is basically the magnitude of z. Then cos of theta plus iota sine theta. You can easily calculate this. If anyone wants to calculate the mod of z is what? Mod of z is root of x square plus y square. See, mod of z is what? Basically the length of this vector. So if this is, let's say, x comma y, so from origin the distance of this point x comma y will be what? Root of x square plus y square only. Here, and this theta will be what? Theta will be tan inverse y by x, and people call it what? Argument. What? Argument of a complex number. Now obviously argument can take any value, but we have restricted it, and the restriction, so that starts from here to here, minus pi to pi, and this theta, when it varies from minus pi to pi, this is called the principal argument. What? Principal argument. Okay. And while calculating the principal argument, we always check where exactly the point is, and based on that we decide the principal argument. Now for an example, if I calculate, let's say, minus 3 and minus iota 4, let's say this, so you would say that theta will be what? Tan inverse minus 4 by minus 3, so it will be what? Tan inverse 4 by 3. So you might come and tell me that yes, theta argument will be what? 53 degrees, right? 53 degrees, you might say. But no, that's not the answer for this case. Why? Because as we can see, the real part as well as imaginary part both are negative. So that means they have to be here in the third quadrant. So in the third quadrant, if I take it here, so in the third quadrant, what will be the argument? So this angle, I know this angle is 53, so this angle will be 53. So I have to what? I have to subtract from minus pi this 53. This will be called my principal argument. So this much angle will be called the principal argument. So what I mean to say is, always look at the position of the point first, whether it is in first quadrant, second quadrant, third or fourth. Once you do that, then calculate the angle. I hope everyone got this. Okay, guys. What about the Euler form? What is this Euler form? Euler form is being represented like this: r into e raised to iota theta. This is called the Euler form of the complex number. Again, theta is the argument here, and r is the what? Mod of z. Here, so this is your Euler form. Now people might come and say, what is the use of Euler form? So Euler form is very useful because sometimes when you are just taking the higher power of complex numbers, so it's very difficult to use binomial expansion. In that case, you can use this Euler form and you get simpler answer. What I mean to say is, if I ask you to just expand this, you might find it difficult. But if I ask you to do this, you'll say yes, it's very easy. You can directly write like this, right? And based on this, as there is one more property, we'll discuss that property also. So I hope you must have understood what is the benefit of using the Euler form. Okay, this is the argument. Okay guys, so let's solve a few questions and see how can we solve questions. Okay, just before that, let's talk about product and division in Euler form. What happens? What is the interpretation of this? Just imagine when I multiply, let's say there is one number r1 iota theta 1, argument is this. Z2 is another number r2 e raised to iota theta 2. When you multiply both of them, what do you see? r1 into r2 e raised to iota theta 1 plus theta 2, right? So what it seems? It seems as if when we multiply two numbers, their arguments, they added up. Similarly, when we divide two numbers, what do you see? Apart from their magnitude division, the arguments, they get subtracted. Now let's try to picturize this. How does it look like? Let's say there is one complex number z1 having argument theta 1. Now another number by another number, which is z2, you multiplied it. So when you multiply it, you get another number, the third number, which is having magnitude what? Magnitude is what? Product of both the complex numbers, and it was rotated. It was rotated by the z1. Your z1 was rotated by theta 2. Then you got this complex numbers direction. Okay, so if you just see the total argument for this number is what? Theta 1 plus theta 2. So z1 got rotated by theta 2 and you got the third complex number. So one example and one very good interpretation. So people do this a lot. Let's say there is a complex number z1, mod of z1 e raised to iota, let's say theta 1, and they multiply this complex number with iota. Now when you multiply with iota, see what happens. Only iota. So iota has single magnitude. So let's say, I'm sorry guys, let's say this was the vector and it had the argument, let's say this theta 1. Now when you multiply this with iota, what happens? Unit vector, so your magnitude remains the same. So this vector will move, but by which angle? See, this is iota. So if I want to write this in Euler form, what it is? It is e raised to iota pi by 2. So that means my vector, my z1, will rotate by pi by 2 angle without even changing its magnitude. I hope everyone got this. Excuse me guys. But if you multiply with minus iota, what happens? It moves clockwise by 2. Hi Yusuf. Hello, could you please help me for a maths exercise? Yes, I can do it. Excuse me guys, someone wants help. Yusuf says x and y verify the system. You have to solve that TOT. What's that? What you can do? What you can do is you can easily find out x minus y. It's very easy. X minus y, you can just do it. X minus y is what? X plus y whole square minus of 4 times xy. Do it. You'll get x minus y. Then you can just simply solve for x and y. You'll get two equations. No issues, Yusuf. So you can solve it. I have told you the way. You can just convert this into another linear equation in x and y, and you can solve it. So that's the interpretation of multiplying with iota. Here. Now what's happened when division? So let's say if your you have a number z1 and argument is theta1. When you divide it by z2, so what happens? Obviously your magnitude gets divided by mod of z2, but your argument changes. It goes back, or you can say it goes in the clockwise direction by theta2. That's how you get the new complex number z. This is z, your mod of z1 plus z2 e raised to iota theta1 minus theta2. Okay, I hope you must have understood how this vector, this complex number vector moves with the multiplication and division. Okay, fine guys, let's solve this question then. There is a complex number z, which is r, your is magnitude e raised to iota beta. Then we have to prove that mod of e raised to iota z, here z is equal to what? This e raised to minus r sine beta. So it's again very easy question. What do you need to do? First we'll find out this complex number, what it is. E raised to iota into r times e raised to iota beta. Clear? That's how we'll write. Now if you want to play smart, the way I told you, what is the interpretation of multiplying with iota? What it means? It means that your magnitude will remain as it is. It is just your complex number will get rotate by pi by 2 in anti-clockwise direction. E raised to iota. Now the argument will become what? Beta plus pi by 2. That's it. Right guys? Okay. So this is what you need to be worried about. If I want to expand it, so how will I write it? E raised to r cos of beta plus pi by 2 plus iota times sine of beta plus pi by 2. So what it is? E raised to r. This is what? This is second quadrant. So second quadrant cos is what? Negative. So sine of beta plus iota sine, here it is positive. So this is second quadrant, sine will be positive. So it will become what? Cos of beta. Clear? Till here everything is clear. So I can rewrite this as e raised to minus r sine beta into e raised to r iota bar cos of beta. I'll keep it out because it's a constant, and this is what? This is a uniform modulus complex number, right? I can write it as cos of r of cos of beta plus iota times sine of r of cos of beta. So if you take the mod of this number, what do you get? This is the mod. So mod of e raised to iota z will be what? E raised to minus r of sine of beta. That's it. It's a very easy question though. Just give me a moment guys. Yes, Yusuf has some doubt. What Yusuf says? Sorry professor, I'm taking your time. It's x plus y is equivalent. x y or x square y? What do you want to say? It's x into y, right? It's x into y. So that's what I'm telling you, buddy. What you can do is you can first find out x minus y, and it is what? X plus y whole square minus 4 times x y. You can punch x plus y ka value, which is what? 29. So 29 square minus 4 times 198. Solve it. You'll get x minus y ka value. Once you get x minus y, it's a value. You already know x plus y is what? 29. You can solve these equations peacefully. Add both of them. So you'll have 2x is equal to what? 29 plus k. So x will be what? 29 plus k by 2. So that's what I'm telling you, Yusuf. You can do it. It's very easy. I'm not doing the calculation for you, but you can do it. Now let's solve this question. Prove that tan of iota log e a minus iota b upon a plus iota b is equal to 2ab upon a square minus b square. So now see, in this question, when I read this question, the very first thing which hit your mind is what? That it's log and tan of log, and we have to just get rid of this log, then only we can get some answer, right? So how can we get rid of this? The easiest option is if we convert this into what? Euler form. Because once we convert this into an Euler form, things are very easy for us, right guys? Let's do it. So tan of iota log. So this can be written as we can see both are conjugate to each other, right? So if I assume, let's say, the argument for this is what? Theta tan inverse minus b by a, correct? Then the argument for this will be what? Minus theta, yes or no? Obviously it's conjugate, so it would be clear. So this will be the numerator thing, will be what? E raised to iota theta and the mod. So mod, I'll write it here, a square plus b square upon e raised to iota minus of theta a square plus b square. Clear guys? And this will cancel out. Clear? And they cancel out, so finally what is left with us? Tan iota log of e. Finally what do we have? E raised to, this will go up twice of iota theta. Clear? Now as you can see, both are having the same base, so they'll be removed. So we'll have what? Tan iota, they'll remove, so we'll have what? Only 2 iota theta, iota square. So iota square would give you what? Minus 1. So tan of minus 2 theta, minus would come out, so I'll have what? Tan of 2 theta only. So now tell me one thing guys, you know tan theta, right? When you know tan theta, so you can easily calculate tan 2 theta, right? So let's do it, because tan theta is in terms of b and a, so we can easily write this tan 2 theta in terms of a and b. So what it is minus of twice of tan theta 1 minus tan square theta. So minus 2 tan theta will be what? Minus of b by a upon 1 minus b square by a square. So if I simplify it, this will become plus. So I have what? 2ba upon a square minus b square. That's it. Okay guys, and as you can see, we have already proved this. It's a very easy question, right? Yusuf, I hope you're there with me. Okay, so shall we start another question? If anyone is having any doubt, you can ask me, I'll tell you. Come on guys, if anyone has any doubt, you're free to ask. Okay, let's move ahead and solve another question. Okay, so prove that e raised to iota 2m alpha into iota cot alpha plus 1 upon iota cot alpha minus 1 raised to m is equal to 1. So you want to prove it. So how can you prove it? The easiest approach is obviously if you can convert the iota terms into what? Euler form. If you can convert this into Euler form, so then you guess you can easily convert this or convert the entire reference side to 1. I'm sorry guys. Let me just have water. Meanwhile, I would request you guys to solve. When you try solving this question, so what happens? E raised to iota 2m alpha, correct? Let's take the LCM. It would become what? Iota cos alpha minus plus sine of alpha upon iota cos of alpha minus sine of alpha here raised to m. Now looking at this, what you can say, had sine been here, it would have been easier for us, right? So let's do one thing. Let's take iota common from both numerator and denominator. When we do that, what do we get? Cos of alpha plus iota sine alpha upon cos of alpha minus iota sine of alpha. I took iota common both from numerator and denominator. Here. So this will be equal to what? 2m alpha, and this would become what? This is an Euler form. I can write it as e raised to iota alpha upon e raised to iota minus alpha. This is the argument, correct guys? So now this can be written as iota 2m alpha, and this I can rewrite again. Take iota common. This would become e raised to iota twice of alpha into m. We take this iota square. Now this will become iota 2m alpha, but this should be cancelled out, but which we can see this is not cancelling out. Let's see what mistake we have committed. So cos alpha plus sine alpha, correct? This is correct. This is absolutely right. When I take iota common both from numerator and denominator, so we have what? We can multiply with the iota minus 1, we get cancelled out. And this is what? E raised to iota alpha. Go up. So I guess there is some mistake in the question for sure, because I feel it should be minus up, positive down, because if positive it's minus here, positive up, then certainly yes, everything will cancel out and we'll have this sort of term, final term. So I think this is a change in the question. I think this is a mistake in the question. If we do that, what we'll have? We'll have e raised to iota m alpha minus 2 alpha m. It would become what? 0. E raised to iota 0. So cos alpha will be what? 0. Clear guys? I hope everyone got this answer. So cos 0 is 1 plus iota times sine 0. I hope everyone got this. There is a slight mistake in the question. Okay guys, So shall we move to our next question then? Okay. So our next question. But before our next question, we have a concept. So I would suggest you guys, because as I told you in the beginning also, in this chapter we would be moving very smoothly because we want to cover all the basics. So I would request you guys to just revise whatever we have taught today. You just revise it, and tomorrow we'll be talking about the conjugate of a complex numbers, and we'll be discussing about its properties also. Okay guys, so this is enough for today. You can revise it. If you have any doubt, you can just leave a comment and then I'll tell you how to go about it. Okay guys, take care. And if you have liked my video, I would request you guys to just like it, share it with your friends so that they can also learn. You can subscribe the channel. You can just hit the bell icon button so that whenever I come online next time, you get the notification. And people, those who have decided to join Unacademy Plus and Iconic, they can use this code NK001. NK001 help you out to get what? 10% discount. Okay guys, so take care, and you can just recall whatever we have studied today. We studied about the Euler form, we studied about the polar form, we also studied about how to divide, how to calculate the square root of a complex number. So these are the two simple concepts we learned today. We also studied the interpretation of multiplication and division of two complex numbers. That's very useful because using that you would be able to solve many problems based on geometry. I'm telling you guys, based on geometry. So just please revise whatever I have taught you guys today. It's a very small lecture, very concise lecture, so I request please revise it, because this would be required tomorrow when we will be solving more questions and we'll be studying about conjugates, modulus. Okay guys, so take care, have a good day, bye bye.